Alright, so let's take a look at an example deflection angle problem. I'm going to give you the known. So known is we have a radius of 200 feet. Length of curve is 300.00 feet. And the PC is 4 plus 0, 0. I didn't deliberately try to do that, but I went 2, 3, 4. Okay. Okay, so if I write our formulas out, let's see here, we'll write them over here. Alpha A equals SA times D over 200, and then CA equals 2 R sine of alpha A. Okay, so those are the two formulas we need. So based off of what we know, what do we have to find first?
Your SA.
So the SA in this formula equals the chord increment, okay? So it's the subchord distance. Okay, so we're going to figure this out in half stations. Alright, so SA is half stations, right? So if I go alpha A equals, we're going to go 50 feet. What is D? Let's find that, figure that out, right? So D is the degree of curve. So we have to figure out the degree of curve based on this information we were given. Okay? So what's the degree of curve based on the information we were given?
5,721.58 divided by radius.
Yeah, so we can use this formula, but we have to transform it or do some substitution. So if we substitute that, it's D equals 5729.58 over R. So what's our degree of curve there then?
28 degrees, 38 minutes, 52 seconds.
So D is equal to 28 degrees, 38 minutes, 52 seconds. Okay, so we can pop that in here. 28 degrees, 38 minutes, 52 seconds. Okay, so alpha A is what? Remember this is the deflection increment that we're figuring out right now.
Should it be a distance or an angle?
It should be an angle, deflection increment.
Degrees, 9 minutes, 43 seconds.
So it's 7 degrees, 9 minutes, 43 seconds. This is deflection increment. Okay. So we're going to have to figure that out several times as we go through. Okay. For this particular problem, we're not going to because I was nice to you on this particular problem. The next, we can do another problem if you guys want to do another one after we're done with this that has a different, we'll have to figure out the increment twice. Well, 3 times we'll have to figure it out. So, but this one, we will only have to figure that out once. Alright, so let's figure out CA then. Okay, because now we have all the components to figure out the subchord. Or incremental chord, sorry, incremental chord. So CA equals 2 times R, which was 200, times the sine of this guy that we just figured out. 0.7 degrees, 0.9 minutes, 43 seconds. CA is equal to what?
49.87.
49.87 feet. Alright. So we got all of this information figured out. Now let's start a table. I like to put stuff in tabular format. So start up a table here. Okay, so my first thing that I set up over here is going to be the station. Okay, then I'm going to have the CA, or the incremental chord. My deflection increment. And then my alpha A, which is the deflection angle. My chord for each subcurve from my PC. Okay? Alright, so we're going to go back to the information that we know here. And the known, we were given that the PC is 400. Okay? So our PC is 4 plus 0, 0. They give that to us. And we want to figure it out at half station increments. Okay? Well, I want to figure out what my PT is so I don't go too far with my stationing. I don't go past the PT. So how do I find out what the PT is based on the stuff that we've been doing? What's the little formula that gives you defined PC plus L? Give us the PT. All right, sounds good. So the PT is equal to PC plus L. Okay, so I'm given the PC and I have L. So if I add those two together, it gives me 700. So my PT is 700. Or 7 plus 0, 0. Okay? So I'm going to go in half station increments here. 4 plus 50. 4 plus... Oh, sorry. 5 plus 0, 0. 5 plus 50. 6 plus 0, 0. 6 plus 50. 7 plus 0, 0. And that's my PT. Okay? Alright, so that was easy. Set that up. That was quick. Now let's talk about our incremental chord. Okay, so that subchord, that is the incremental chord, the CA value. Now, for the 4 plus 0, 0 station, there shouldn't be anything across from that. Okay, because that's the PT. So there's not going to be anything across from that. But if I want to go out to 4 plus 50, what's my CA? 49.87, which was what we figured out for the first number. So I'm going to put that in there. 49.87. Okay. And we already figured out our deflection increment, which is here. So that's going to go across from 4 plus 50, because that would be the angle that we would have to turn. That 709.43 is the angle that we'd have to turn from the tangent to get to our 4 plus 50 station. Okay, so it's 0.7 degrees, 0.9 minutes, 43 seconds. which we already figured out here, or here. Now we have our deflection angle. Oh, it's the same thing, right? Our deflection angle is the same there because it's the first one that we're turning. It's the 50-foot increment. So I'm just going to copy it here. Not going to happen every time. Okay? And then our chord is the same too because it's the first call. So our chord, we figured out 49.87 feet. Okay. Now here's where the first one's always the easiest one to figure out. Now you got to think about how these calculations go together. So this is why we're going to repeat this calculation, the alpha A calculation, the deflection increment calculation. We're going to do that one several times. And then we're going to do the incremental chord calculation several times through this whole thing. Now, the incremental chord, CA, is going to be the same down through here, okay? But when we're figuring out the full chord from the PC to our station we're going to, that's where we're going to have to change the CA value in here. We're going to have to change this equation, okay? So that means we're going to have to change the deflection angle in there too. So for the incremental chord, for this particular problem, I can copy this 49.87 all the way down to the bottom. Every 50 feet. Okay. So that stays the same. Same with the deflection increment. That deflection increment can stay the same all the way down. Okay. On this particular problem. There's other problems that may not happen. All right, so now we filled in these columns, which is pretty easy. It was done from the first calculation we did. Now we want to fill in these two columns here. So we're going to have to go through and do the calculation for these two formulas with the information that we're going to be given here. Okay. So let's figure out the deflection angle first. Equal to SA times D over 200. All right, so for this first one, we're going 100 feet from the PC because we're going to go 5 plus 0, 0 to get this angle. Okay. So 5 plus 0, 0, that's 100 feet of change. So our SA is 100 times D, which we already figured out, and D is 28 degrees, 38 minutes, 52 seconds, and that's divided by 200. So what is alpha A for 5 plus 0, 0?
14 degrees.
14 degrees,
19 minutes.
19 minutes,
26 seconds.
26 seconds. Okay, so it's 14 degrees, 19 minutes, 26 seconds. Do you see a pattern there? It's already starting to develop. So it's basically 070943 plus 070943, and it gave us this number. So now if we add 070943 again to this, it's going to give us the next one, and then so on, all the way to the end. And there's going to be a check here when we get to here. Okay? And I'll show you that check once we get there. So as you go, tell me these numbers as we go down. Let me know what these numbers are. Same equation here. You can do it this way with the same equation, or you can just add these up to each one incrementally. So when someone gets 5 plus 50, let me know, and I'll write it down. I'm going to go sharpen my pencil. It's dull.
21 degrees.
21 degrees.
29 minutes, 9 seconds.
Okay, anybody else concur with that? Okay. Same thing, but now it's going to be times 200 because we're figured out for 6 plus 0, 0. 6 plus 0, 0 is 200 feet from the PC. So you're going to use 200 here instead of 100 to figure out this one.
28 degrees, 38 minutes, 52 seconds.
52 seconds. Anybody concur with that?
Yes.
Okay. Now the next one, we're going to basically use, instead of 100 here, we're going to use 250 because we're out to 6 plus 50, which is 250 feet further out than 4 plus 0, 0 at the PC.
Degrees, 48 minutes, 35 seconds.
Okay, and then our last one, we're 300 feet away from number 4, or from 4 plus 0, 0 at 7 plus 0, 0, so we're going to use 300 here.
Degrees, 58 minutes, 18 seconds.
18 seconds. All right, so we figured these all out. Well, remember I said we're going to have a check here pretty quick, right? So our check right here is that this should be half of I. Okay, this number here should be half of I. Well, were we given I up here anywhere? No, but we can calculate it, right? Because we have D and we have L. So we can figure out I. So if I go on here, I is equal to LD over 100. So that would be L is 300 and D was 28 degrees, 38 minutes, 52 seconds divided by 100. So I equals what? This is just a check.
85 degrees, 56 minutes, 36 seconds.
Okay?
And divided by 2,
Divided by 2 is...
42 degrees, 58 minutes, 18 seconds.
Okay, so if we divide I by 2, it's 42 degrees, 58, 18. So we have our check there. This check's okay. Right? So we're good. Alright, so how about this one here? We should probably check this too to make sure. This should check okay also, right? Because if we add all these up, we should get 42, 58, 18. And I'm pretty sure that checks okay. So it checks okay. Alright? Now, next step. We want to find CA for this column, the chord length for this column. Well, we just figured out all the angles that we can use in this calculation. Oops, sorry. A little high there. We figured all these angles here we can use in this calculation right here. We're just going to have to change, well, actually, we don't have to change anything.
Just,
So all we have to do is change the alpha A
yeah.
for each one of these values. And that's going to give us our chord length out to that point on the full station, or half station, whatever we're figuring out. Okay, so for the first one here, we already have it, but how about for 5 plus 0, 0? So that calculation is CA equals 2R sine alpha A. So it's going to be 200 sine of alpha A at 5 plus 0, 0, which is 14 degrees, 19 minutes, 26 seconds. So CA should be what? For 5 plus 0, 0 should be
98.
98.96 feet. Okay, so what that means is if I'm sitting at the PC here, okay, if I'm sitting at the PC, I'll draw it out here. So say our curve looks like this. I'm sitting at the PC right here where my total station is set up, and my PT is out here, or PI I mean, PI is out here, and I'm backsighting my PI. Okay? I now, if I want to go out to 5 plus 0, 0, need to turn the angle of this angle of 14 degrees, 19 minutes, 26 seconds, okay, for my straight line chord here to 5 plus 0, 0. So I got to turn 14.926, or 14 degrees, 19 minutes, 26 seconds, and go out a distance of 98.96 feet. And that gives me station plus 5, or 5 plus 0, 0. Does that make sense to everybody? Hopefully? Okay. So subsequently, if I was doing 4 plus 50, I'd just go 7, I'd turn 7 degrees here, and that'd put me at the 4 plus 50 here. And go that distance, 49.87, would give me it there. Okay? And then so on. You'll just keep on laying out that curve based on that way. Okay? So let's do the calculations for the rest of these then. Can you give me the distances for the rest of these? Using this formula again, but for station 5 plus 50, which now you're going to use this angle for 5 plus 50 to figure that one out.
146.51 feet.
Okay? 146.51.
6 plus 0, 0 is 191.77.
191.77.
6 plus 50 is 234.04.
234.04.
And 7 plus 0, 0 is 272.65.
272.65. Good. All right. So, the other thing that we could check here is if we calculate our chord, our long chord, we'd be able to have a check for this number, this last number here. Okay? If we were to figure out our long chord. So we'd have to we'd have to take and do LC equals 2R sine of I divided by 2. Or D. Same thing as what we just did. Okay? So that's what our long chord is. Should come out to this. That's our check. We're good to go. So that's how you solve a deflection angle problem. The reason we do that is so that way we can lay out a curve, essentially. Lay out by deflection angle. Does anybody want me to do another one? Or are they good with this as it sits right now? Speak up or forever hold your peace. I'm willing to do another one, or you guys can have work time to start tackling. Well, finish the homework you got going right now. Let's do by the end of class. And you could tackle the deflection angle problem that's on Blackboard for you to turn in. And remember, you turn that earlier, you turn that in, earlier you get it back. So, anybody else want me to do another one? Or are we good? You can always ask me questions. I'm here for the whole class period.
I mean,
So.
they'll all be pretty similar to this, but we might
Yeah.
just change the
Yeah.
station size.
So what might happen is I might give you a station of 3 plus 89 here, and you have to figure out that small increment to go to 4 plus 0, 0. So that 11 foot, you have to figure out that 11 foot increment. That's where you might have to figure it out again. And then when you get to the end of it, depending on the curve length, you might have a small increment that you'd have to figure out. You know, say it came to 6 plus, figure out that 49 foot or 39 foot increment to go from the 50 foot station to the tangent or the point of tangency.
you
So
just change your.
you're just changing your numbers here is all it is to get to the whole station. That's all it is. Or half station, whatever you're being asked to figure out. So it's pretty simple to go through. It's systematic, just like everything else.
If your essay isn't a consistent extra 50 feet every station, then your incremental chord will change.
Yes. Yes. So, and your deflection increment's going to change too. So these two items are going to change based on that distance from your PC to the whole station or half station you're going to. So, was this good enough of an explanation for how you're laying out that curve? Or do you want me to draw it out better? No, you're good? All right. We're good to go then.
Well,
Let you rock and roll.